2. Very similar to our last example, but this time now we've got the block and it's got a bunch of forces acting on it. So we've got 3 forces acting to the right. Those forces are 5 newtons, 27 newtons, and 9 newtons. And to the left, we've got 2 forces, negative 14 newtons and negative 47 newtons. And actually, this is technically a misnomer. The fact that I've got the negative 14 newtons going with an arrow pointing this way, these should really actually be positives, because the negative goes into the fact that if we don't have the direction given to us. Remember, a vector is a magnitude and a direction. So in this case, we've got our direction by having the arrow down, so we just have to put the magnitude. But at the same time, when we're doing the actual math, it's going to be up to us to put in the negative sign, otherwise the math will get screwed up. So sometimes it's okay to leave that negative sign in as a reminder of what you need to do when the math gets in. But at the same time, it's important to understand that if you were to have an arrow going like this, and then it said negative 5 newtons, that could also mean what you're really saying is you've got an arrow going this way at 5 newtons. So it depends on what you're trying to say. Now, in this case, I'll leave it as the positive 14 newtons and positive 47 newtons over there, but it's up to us to remember that when we add it together to get the net force, we're going to have to pay attention to that. And finally, our block has a mass, the block's mass is 5 kilograms, sorry. All right, so if we want to put this all together, we get a net force. What's that going to equal? It's going to be all these things put together. Well, what's our positive ones? We've got 5 plus 27 plus 9. That's everything going to the right. And then we've got the 2 things going to the left, so plus a negative 14 and plus a negative 47. We add everything up, and that gives us negative 20 newtons. So we put that into our force equals ma acceleration, our force equals ma, F equals ma. So we've got F net equals mass times acceleration. So we've got negative 20 is equal to 5 times the acceleration, which gives us that negative 4 meters per second is equal to our acceleration. And remember, that's going to be going in the left direction. So we've got A over here equals 4 meters per second, which is the same thing as negative 4 meters per second. So remember, it's just a question of whether or not the direction has been shown in our graphics. But this can get confusing sometimes, and it's important to you to be paying attention to what you're writing and what you're meaning by what you're writing. It could be that you'd have a negative sign where you shouldn't really, but the important thing is that you understand what you're doing and that whoever you're writing it, that you're going to show it to, is also able to understand what you're doing.